Thanks guys for coming. 5 years of Gradle at LinkedIn. Let's get started. When I was a young engineer, I've always wanted to create a build tool that would be the best and that would rule them all. About 5 years ago, I gave up, and Hans recruited me to help him make Gradle the best tool, best build tool out there. And are we getting there, or we are there yet? Well, we'll see. And at that time at LinkedIn, the question was why Gradle? People were asking about it. There was a wiki page describing all the reasons why Gradle was selected. It was not that easy. It was the time, dark age, as Jens says, about version 1.7, 0.7 or 0.8. But fortunately, LinkedIn was an early adopter of Gradle. And for any emerging technology that is relatively new, that does not yet have the reputation, if a big firm comes in and is able to help out by being an early adopter, by sponsoring some features in open source, that's a great and wonderful thing. So thank you, LinkedIn, for helping out. What happens next? So why Gradle? So many engineers at LinkedIn at that time were asking why we are using technology that is not even 1.0. So I want to stop here because there is this fear out there that let's not use version 1, let's not use a technology until it's matures enough to be 1.0. So even though a version is just an arbitrary number, there is some magic about 1.0 or 2.0. Like for many engineers, it's the matter of stability and quality. So we were waiting for Gradle 1.0, and what we have learned is that camping at versions below, major version below 1.0 is not a good idea. It just does not help promoting the technology. It does not help growing the user base. So do not camp. If you build your libraries, whether they are external, open source, or internal in your organization, like try to have a regular cadence of major version releases and go for 1.0. Interestingly, before Gradle reached 1.0, we always thought that the daemon must be turned on by default. And we actually had a quite long short list of must-haves for 1.0, having the daemon turned on by default as one of the examples. And I don't think that was really successful. It was slowing us down from releasing 1.0. There were this madness of milestones at that time. So this default daemon is an example of a self-imposed constraint that prevented us from releasing this major version. Fortunately, Hans said at some point, guys, we can't be always wanting those must-haves to appear. We need to release next major version. That's why we released 1.0. And that was great. Everybody rejoiced. Gradle 1.0 for many is a sign of maturity and stability, so Gradle user base grew. Another cool milestone for Gradle was the fact that Google and the Android selected Gradle as a backbone of the automation for Android. And that's a huge thing for any technology. This is like a very strong message that Gradle is the tool that we bet on. And this was another big uplift in the user base. And it helped us also at LinkedIn to promote Gradle, to push it towards mainstream at LinkedIn. Then there was Gradle 2.0, awesome. Again, we had a bunch of must-haves for 2.0. At some point, we decided, stop, let's do 2.0. And 2.0 happened. And right now, the question, why Gradle, that I heard at LinkedIn 5 years ago, it's completely flipped over. Right now, it's why not Gradle? So if there is some automation challenge at LinkedIn and somebody chooses a different tool than Gradle to satisfy these requirements, people will be asking why you're not using Gradle. Because Gradle is so good in doing automation. And we've done a bunch of good things with Gradle. Right now, we have more than 2,000 projects that are built with Gradle. It's probably close to 2,400, I believe. We've got more than 100 plugins. And I'm talking public plugins like that have the identifier that can be used and that can be consumed by the end users. There are a bunch of internal plugins that are even more than that, I believe. And what we do, we automate not only the JVM projects. So JVM is a very natural platform for Gradle. So you're gonna, if you start a modern Java application without, and you choose a different technology than Gradle, well, I don't think it's a good idea. 2015, come on. At LinkedIn, what we do, we also drive the C++ projects. What we also do is we put a lot of effort into making the iOS development consistent and clean and stable. It's a lot of fun to drive the Xcode tools. Python. Python Foundation team at LinkedIn was pretty excited about the dependency management that we could introduce to Python projects through Gradle. And finally, this year, we embraced JavaScript and surrounding technologies like NPM, Node, or Ember, or Bower. So they are all integrated at LinkedIn. Our goal for JavaScript integration is to make the developer experience when working with those JavaScript tools and frameworks better than if you use the open source workflow. I'm not sure we are there yet, so we're still improving that. But that's the goal. Finally, Gradle plugins at LinkedIn, they are a platform. What it means, like platform has an API that you can code against. Platform has an API, which means that any team at LinkedIn can develop their own suite of Gradle plugins, and they can leverage the APIs and the capabilities that we have. And this is working very well for us. But before we got to the point that we need a platform, we started in a standard fashion. The handful of plugins that we had 5 years ago grew to a monolith. So we had a bunch of plugins in a single spot. It was not convenient to work with that. I guess what we've reached is an inflection point. As the system grows, at some point it reaches the point that it's big enough for any change to be difficult and hard and expensive. So we've learned that modularization is the key, and that's what we've started to do. So we modularized the plugins, and the platform API that came out of it was one of the outcomes. And modularization is like, we see it very often, like even Java 9 hopefully will bring in the modular architecture, like systems learn, or people who maintain systems learn, like at some point you've got to modularize. So let's switch gears a little bit into specific use cases that we wanted to satisfy with the build automation and with the engineering tools at LinkedIn, and how Gradle helped us. Before I start, I want to talk a little bit about the multi-repo versus mono-repo architectures. So mono-repo is when you put all your source code into one gigantic, badass source repository. And multi-repo is, I guess, more standard approach. Many companies do multi-repo. It's like you have multiple source repositories, and typically team owns a single repository or runs a couple of them. But generally, there are a bunch of repositories. And I believe that LinkedIn started as a mono-repo. We still have this huge project that was driving the scalability of Gradle. I don't know how much memory Gradle needed to run this project at the very beginning, but it was way more than 64 gigabytes, as Jens said, because we've been like, when the build was running for 5 minutes, it reached the maximum. So if I would let the build run for the 2 hours or so, it would use like all the memory in the universe, I think. But we gradually, added a bunch of improvements, mainly performance improvements. We reduced memory footprint, and Gradle was able to scale enough to be much better than the previous solution. It was really mad, like a conflux of ant builds with very sophisticated custom ant task parallelization and distributed building. So it was really complicated. It was not really scaling very well. With Gradle, we achieved something better. This project is shrinking as we speak. It's much smaller these days. We basically moved that to multi-repo architecture, where basically those are separate components that are integrated at the binary level. So I guess coming back to multi-repo and mono-repo, at some point, LinkedIn decided that multi-repo is the architecture we will invest in. So with mono-repo, there's a problem with scalability. If you have huge repo, it does not scale very well. With multi-repo, you have different challenges. And let me talk about those challenges because Gradle helped us overcome those challenges. So one of the problems, if we have multiple repositories and multiple products, we call them products, those projects that the team works on. So the validation, cross-project validation. So if you have single repository, when you make a change, you immediately see if that change breaks some of your internal consumers in the same code base. Like the build fails, IntelliJ shouts at you, hey, something does not compile, some test does not run. When components are integrated at the binary level, if you introduce a problem, you will find out that you have introduced that problem only when the client of your code starts consuming a newer version that contains that problem. So this validation is sort of deferred, and we didn't like that. We wanted to have a better, cleaner validation, something that you normally for free get with a single repo or mono-repo architecture. But we still wanted to invest in multi-repo. So at LinkedIn, all consumers of your software component, be it a Java library, a jar, are automatically rebuilt every time you push a change to master. So you push the change, and what happens is that CI infrastructure kicks in, and it runs all the consumers of your jar with that new changed version, this new changed jar. And only if every consumer is happy, there is a new version published. Automatically, we publish a new version of that software component. The API from Gradle that allowed us to do that is the repository API. So this is something that, like, majority of people don't use that frequently. You just declare the repository and that's it. You forget about it. But I want to highlight that we really like the fact, and it was very important, especially early, when LinkedIn bet on Gradle, that we can flexibly configure the repositories. We can not only work with file system, we can work with Artifactory. So we can specify the location where the release candidates can be from before we actually publish those release candidates to the official LinkedIn repository and then being consumed. So the infrastructure and the mechanisms of doing those dependency testing, I think a repository API is something that really helps us. Another interesting use case that we had is versions galore. So if you have a single repo, there's no problem with the versions. But if you have in your organization multiple projects and they work together, you have this problem that, OK, I want to use that jar, but at which version should I use it? There are like 200 versions of that jar. Should I go for the latest version? Well, I mean, maybe not. Latest is like a bleeding edge, so I don't want to bleed. So let me go 2 versions behind or something. So, and then at some point, you also can discover that, OK, I produce this jar. I have a bunch of customers, a bunch of projects use it. Now let's see at which versions they consume. And then you see that there are like 50 distinct versions that people are used. So it's a risk. It's a liability. Like in theory, it means that if someone discovers a problem, and he's very many versions behind, there may be significant effort to upgrade him to a newer version. So there is this problem with the proliferations of versions. And there are a couple of ways that we solve that at LinkedIn. So one of the things I wanted to show is that at LinkedIn, what you can do is you can declare a dependency to a wildcard version. So the consumer at the top depends on the software component 2.*, meaning that with every build, he'll get the latest and greatest version. So at LinkedIn, we considered the latest version, the newest version, the last known good version. So I guess the best version that you can use. But that's not necessarily true. In certain scenarios, the version is different. An example of that scenario is that if we discover a problem in the latest version, we have ways to end of life that version, and then those products that depend on the wildcard version will pick up the prior version. So I'll talk about that a little bit later. But for now, I want to stop here to explain that use case. So imagine those customers that consume that component at various versions. And how does the dependency build mechanism work here? So what happens is that if you make a change in the software component and push that in, all those customers are rebuilt with the newer version. Even the customer that is built with version 2.1 is going to be rebuilt with the newer version of that. This is how we want to embrace semantic versioning and make sure that that there are no backwards incompatible changes. Okay, this consumer here uses an old version. I'm going to have a quiz question for you about that soon. So let's get to that a little bit later. So dynamic versions is a way at LinkedIn to declare a wildcard version. So I don't lock in the version that I use. Basically, bring me the latest and greatest. This introduces a pressure in our environment to always consider backwards compatibility and make sure that you only introduce backwards incompatible changes with the major version. Another mechanism and tool that we have is push my upgrade. So this is when you want to roll out an upgrade of your library to all the customers. So you have a way of doing that. It's done automatically. So you issue that, and those customers are rebuilt. And if the builds are happy and the validation succeeds, they are automatically upgraded. One other feature that we have at LinkedIn is the EOL for versions. So we can decide that a given version of a given product is no longer good. A classic example is that we discover a problem late in the game. So automatic validation failed to discover a problem. So we already published a version. What do we do now? So we can end of life a version. Another case for that is for old versions. Let's say you release a version 2.0 of something. You want to deprecate the version, the 1.x versions, all the 1.x versions. And then let's say 6 months from now, those 1.star versions will be end of life. So the builds will not succeed. Like there's going to be a build failure saying, hey, I'm not going to build this. You're using old version that has been end of life. So that's an example. At LinkedIn, we also have a bunch of ways of tracking versions. So you know how many customers there are of your library or a software component, and at which version they consumed your library. Couple of APIs that we leverage at LinkedIn to make it possible. One is the dependency resolve rules API. This allows us to have a fine-grained control over the dependency resolution at Gradle. So, for example, we can change the versions that are being resolved during the resolution. We can make decisions during the resolution. We can even swap the name of the dependency if needed. So this is very nice API. Okay, so switching gears to compatibility. I want to stop here a little bit because this is, I think, the most interesting part. And at LinkedIn, we do want every team to embrace semantic versioning. And semantic versioning in the broader aspect, it's not only about just putting the right number, but it's also about like different style of engineering. Like you really need to think through the API between two software components that are integrated at the binary level. It's like changes of the public API are not as convenient. Like you have to maintain compatibility. If you make a change, you have to update your clients. So there needs to be more thought and design put upfront into designing the API. And also, there needs to be a clear distinction between the private API and public API. And that's a great thing. I really like that. This is like one of the really nice engineering challenges to do it right. With the architecture that all your source code lives in a single repo, there's no big pressure into getting the public and private APIs right because all those components are in the same repo, so you can always refactor, do whatever you want, which is, on one hand, a good thing. Nevertheless, I like this idea of putting more thought into the design and coding before actually implementation. And given that at LinkedIn we want to embrace semantic versioning, I have a quiz for you. So in that example, let's imagine that in software component, you have introduced a change, and you pushed that change into the source control. It went out to the master. And the CI machinery kicks in and starts rebuilding the dependencies. the dependence. So guys that depend on that software component. So what happens is that, let's say those consumers that are version 2 point something, they all are green and happy and successful. But this guy fails. The 1.9, the customer that uses version 1.9 fails. Now, should we, in that circumstance, should we allow the publication of new version of your change with that component or not? What do you say? No? So at LinkedIn, we want our tools and to also match semantic versioning. And what semantic versioning says is that those are not the same major versions, which means that if this guy fail, like, come on, go up to the 2.0 version, migrate, right? So the developers will get information that this fails, but it will not prevent the publication of the new version of the software component. Obviously, there's much more to that. If this is a change that potentially can break, it should be well documented and stuff. This team should be notified. So there's more to it. But I want to highlight this example as an example how we want to approach semantic versioning at LinkedIn. And Gradle is very much semantic versioned. Like the team puts a lot of effort into maintaining backwards compatibility. And I think that's awesome. The level of testing at Gradle, automated testing, making sure that like stuff works with older versions of Gradle, newer versions of Gradle, it's magnificent. So to run the entire suite is like so long it takes, but at least the validation is just fantastic. And we're waiting for 3.0. So, OK, so another interesting use case are the version conflicts. So at LinkedIn, we want to get it right, the version conflicts. Like we decided that we go for multi-repo architecture. With multi-repo, there is a problem of version conflicts because there are so many versions. And there might be incompatibilities. Like we can have a component that transitively pulls in the version that we don't like. So let's stop here and let's discuss that, how we did approach that. And on the side note, I want to tell you that version conflicts are much less like relevant if you have single repo architecture, because in the single repo, like components depend on each other at the source code level, right? So like they are part of the same single build. Like you will find out about any incompatibility immediately. You don't depend on the version. You depend on like on the code itself. So the version conflict is very much relevant if you have multi-repo architecture, if you have scattered small components out there that integrate at the binary level. So at LinkedIn, what we do is we have custom conflict resolution. So it's a little bit different than the one that you get with stock Gradle that you get from open source. And how we do it, let me show you on a couple of examples. So in that example, we have an application. So let's say we are product owners of that application. It depends on util and library that brings in a different version of a util. So what happens here, for us at LinkedIn, this is a healthy situation. We, as a product owner, we declare that we want to use 1.1 of util. And at runtime or during test execution, during compilation, 1.1 will be used. So the conflict resolution will get the latest version. Actually, at LinkedIn, it's not like that. It's conflict resolution chooses the version that the product owner has declared. So for good or bad, that was the decision taken on pretty early, that we need to have, that the product owner needs to have control of the versions and does not allow like some kind of different version that he declared to be consumed by his build during compilation, during execution of tests, or during runtime. So, so far, this is working well for us. And let's get into more interesting cases, because this one, I guess, matches the Gradle open source, like a stock Gradle behavior. Now, what happens with this? What happens during this scenario? So now the product owner declares the version of util that he wants to use at 2.1. But we are consuming transitively util 2.2. So what happens? Should we? Well, at LinkedIn, we have this rule. The product owner gets to choose. But what do we do with the build? Like this library might depend on some new feature, new method that was added in 2.2. So if during the runtime we're going to select util 2.1, library might not work correctly. So this might not work for us. So what we do in that case is we fail the build early, saying that, hey, what's happening now is that you have selected util 2.1, but but the outcome of that is that we are downgrading one of the transitive dependencies. We are downgrading the util. And this is undesired, because this may break library. So what we do, we flag that scenario, and we prevent the build. And this is another interesting example. So let's imagine that the product owner selects the version 3.0 of a util. And transitively, we pull in 2.9. So what do we do here? What do you say? Should we allow it and basically select 3.0? Should we flag it as risky? What's your thoughts? 3.0? So we could use 3.0. Like, there's a chance that 3.0 is backwards compatible with 2.9. However, like, we believe in semantic versioning. We believe that people actually wait with the breaking changes and include those breaking changes in the next major version. So 2 and 3 are different major versions, which means that most likely util 3.0 introduced backwards incompatible changes, which means that things will not work correctly. So we're going to stop that build early. So this is not a downgrade. It's like an upgrade. We are upgrading the version of util, a transitive dependency, but we are upgrading a major version, like more than one major version. That might be risky. So we flag that early, and we prevent that. So those are the examples on how we do conflict resolution and how we fail early. Few other things that we have implemented is that we also embrace the concept of releasable units. So we don't allow a situation that you consume a API and an implementation of the same thing at different versions. So within a product, at LinkedIn we call them product, like all the jars and all the components that are published as a part of that product, they will be used at the same version when they are consumed by some other products. So I like to call it a releasable unit, because those are like pieces of software that were tested together, that work well together. And if they are a part of class path somewhere there by someone else, they should not be, the version should be consistent. How do we implement that? We use dependency resolve rules API. I mentioned that earlier. We use resolution result API. This gives you access to the resolved dependency graph. So you can basically navigate the dependency graph. You can find out, oh, this version has been selected, why it was selected. So you have full control, and you can add some validation. This is what we do. We also leverage the module replacement rules API. This allows us to conveniently inform the conflict resolution that that component has been replaced with some other component that has a different name, different identifier. Traditionally, the conflict resolution works very well if the incompatibility is only with the version, right? If the identifier is exactly the same, so the group matches, the name matches, but there's only difference with the version. So in those scenarios, conflict resolution works reasonably well. Now, when you have a situation that a library was replaced by something else, like a different name, and this happens when, let's say, that was old times, but those are the examples that I came up with. So Spring, when it moved from 2.0 to 3.0, right, it's been modularized into smaller components, and the names didn't match. No, the names of the libraries didn't match. Like, the conflict resolution does not really work with that case. The classic example is Google and Guava. So at some point, so we had a number of problems with Google and Guava years ago. Now everybody uses Guava at LinkedIn, at least those teams that need Guava. But previously we had issues in runtime because there was an incompatible version of Guava and Google Collection on the same class path. With the module replacement rules API, we could mitigate that problem, actually completely resolve that. We could inform the conflict resolution and tell him, hey, Guava is actually the replacement of Google Collections, so don't allow both of those guys on the same class path. Prefer Guava. So a few other things. So another use case is the cross-repo refactoring, something that it's difficult. Imagine you have multiple repositories. How do you do refactoring across those repositories? And then even if you manage that in some way, how are you going to achieve the atomicity of the commit? So for that, at least, so let's move out the atomicity of the commit from the picture, let's focus on the refactoring, kind of working across multiple repos. For that, we will use the composite build API from Gradle. Have you guys used the composite build API? Anybody heard about that? I'm not surprised. It has not been developed yet. So we're working with Gradle to get that, to make it possible, so that you can basically compose your distinct and separate Gradle builds into a single build, which will solve the first piece of a puzzle of this cross-repo development and cross-repo refactoring. And then the next phase will be how to actually commit that safely to the source control. Basically, at LinkedIn, we really don't want to have this debate like mono-repository or multi-repository. We want to implement all this. We want to make the developer experience just the best. So we want to basically have all the use cases and the standards, nice behavior of a mono-repo in a multi-repo architecture. So we want to have a fast validation. We want to ensure that we don't introduce backwards incompatibility changes. We want to have a cross refactoring. And also, if a team chooses to be one big project, we also want Gradle to scale and support that. So basically, we want both. We want basically everything to work well. The next 5 years. LinkedIn is very interested in funding disruptive changes in Gradle. So we don't want like small improvements. We want game changers, like things that transform the developer experience. Like I want to show you one example that we plan on achieving in 2016. So on the top, it's traditional way of sort of working with the code. You check out, you do some coding, you build, you inspect the result, and you commit. Like there are various variations of that, and sometimes this is pushed out on the CI machinery, but essentially this is how it looks. Now in 2016, we want to check out and basically work on the code. So the build is automatic. It's in the background. It gives us status immediately when it happens. Like imagine like you work in IntelliJ or maybe Eclipse, but probably in IntelliJ. So you make a compilation error. You don't do that normally, but that was a bad day. So and then what happens? Like you immediately see that you broke something, right? You see those red things in the IDE telling you, hey, there's a compilation error. You don't have to run the build and analyze the output of the build to find out that there is a compilation error. And this is exactly when we want to get the developer experience of building software. We don't want him to invoke any build. We don't want him to wait for the build to finish. We want that to be automatic, to be in the background. So we're gonna like leverage everything that the Gradle daemon can give us. And for the developer builds, we basically want 0 seconds builds. We don't want you to run the build at all. We want you to see the output. Like if you are writing code that breaks tests, we want to tell you that you have broken tests, but there's no build involved. Like we want that to be possible. And that's our goal. And with that, I want to say thank you for coming. And I think we have time for like maybe 2 questions you might have. Yeah?
So my question would be like, LinkedIn, like how do you internal things?
Oh, it's a great question actually. So how do we manage the artifacts from outside, like the external artifacts, external dependencies, like let's say JUnit or Mockito, correct? So at LinkedIn, we have this rule that we don't want the teams to reach out to the web and download whatever they want. It's mainly for the legal reasons. And so the official repository is internal, you need to have, let's say you want to have a newer version of JUnit that you want to work with, there's an automated process to get JUnit. So JUnit is a known library, we know the license, we know it's good. So there's a pretty fast automated process for getting a new version automatically added to our Artifactory so that everybody can use it. And that's how it works. You basically you use some service that we have that we built internally. Hopefully that answers your question. Yep.
Yeah. Do you or are you doing the same?
Okay. So the question was like, how do we test the releases? I guess. How do we? What's the developer experience when they want to release a change out there, or when they want to just not release? They just code and iterate. Okay. That is a great question. So. I come back to this semantic versioning. One of the other things that we want to embrace is continuous delivery. So our goal is that to have everything continuously delivered, be it an application that goes out there, or it's a library, we want all that to be continuously delivered. So I guess you're asking for like services and applications more or less than libraries, because libraries are easy. You make a change, you push, validation passes, bump, new version is released. What happens with the applications? So with the new JavaScript tools that we offer and some of the applications that we developed in 2016, like we have rules that one of the teams that I work with has this rule that there are 3 releases to production of the application. It's like a web application, big application, 3 releases to production each day. The maximum time from a code to checked in to release to the production is 3 hours. So we don't give like a different developer experience for testing. Basically, we want everything to be automated. Hope this differs from team to team, and also it differs from, sometimes you have some constraints. You are not able to publish like 3 times a day to, let's say, App Store. But generally, I think we want to invest as much as possible to automated validation and basically embrace continuous delivery. So I'm happy to receive questions after this. Sorry, guys, Hans is next. So
Use the microphone in the middle. We can take a couple more.
Oh, you want to take questions? OK, cool. So I think we can spend another 5 minutes to have a few more questions. So you might have? OK. So whether we run tests in parallel. Yes, we do run tests in parallel in various ways. So we run them in parallel on a developer box. Or we also run them in parallel in distributed. So really various ways. So you say that debugging tests that run in parallel from IntelliJ is not great. Well, my suggestion is that for debugging, don't run them in parallel. For debugging, you just need to find a reason. So, like, I'm sure there's a so Gradle. Let's fix that in Gradle. Your pull request maybe. So next question.
I'm curious how every build a new version.
Oh, that's a great question.
So how do you deal with version scale?
Oh, that's a great question. So, like, no, we don't use snapshots. No way. We are not using snapshots. Snapshots don't make sense, at least to me.
And then
So,
how long do you keep builds around? If
So-
I built on something you built a year ago, can I still repeat my build this year?
it's a good question. So, let me step back a little bit. So, we use snapshots for like a really local development. So, if you work on multiple products that consume each other and they are on your local, then we're going to use the mechanism of snapshot. But we never publish snapshots out there. Like every change is a new version that is released. So that's one of the rules that we have. And I kind of forgot the question. Oh. So the recreating a build from a year ago. So what's happening is that we, like with every build and with every publication of a new version, we publish some kind of we call it a build spec or a receipt. Like it contains information what versions have been used. So yes, there is a way to reproduce that build a year from now. We have also some rules on like purging like old artifacts from our corporate repo. So you might not be able to reproduce the build like, I don't know, that is really old, that uses some really, really old stuff, but we really haven't had a case for that yet. So in a general sense, yeah, you're able to reproduce the build. What do we? Well, hopefully we can. It's education. There's like it's a pain. Like if single team does not follow semantic versioning and breaks often like their customers, and like it's really hard. It's like disheartening. It's like demoralizes. It's like no. There's no good answers for that.
I mean more about external projects that don't follow.
Like external dependencies, external libraries, let's say. I don't think we have like a consistent strategy for that at this stage. We basically do what we can do. Sometimes if we can, we work around that, maybe by using that library differently, building a little bit of the compatibility layer. So that's one of the ways. The only example that comes to me is when we've been developing actually some compatibility layer. So we depend on something, some library, and we support multiple versions of that library, but those versions work differently. So we need to build a little bit of a compatibility layer to kind of shield ourselves from that sort of a problem. But I guess there are other ways. Yeah, hopefully that answers the question. So Hans mentions that we could maybe mark if we have a richer dependency metadata model different than Maven and different than Ivy, a new one. Maybe Gradle can do it, can deliver that. We could have that information included with the software component that you consume, that are you semantically versioned or not. Like, everybody would say, yes, we are semantically versioned because we use 3 components in the version, right? But then, the reality is probably different. Okay? How do I define dependencies in a multi-module project? So, how do I define dependencies in a multi-module project? So, it does not differ from the single module project. So we declare dependencies. We have our own way of declaring dependencies for given product, like a little bit of a. So we don't declare we declare dependencies in that sort of configuration file, metadata file is sort of on top of the build.gradle files where you normally declare dependencies. We do that in order to accommodate a couple of use cases and challenges, but generally. There's no difference, be it like a multi-project build or a single project build, small one, we declare dependencies in the normal way. We're talking about those dependencies to other components that live outside. So we just declare that. We declare at the specific version, or we declare at the wildcard version. So give me everything that is 1 point star. So those are the examples. So maybe this is last question. Sorry, Hans. No, so this is in our specific metadata file that lives with every product, and it's checked into the source control. So he declares the version there. But that doesn't really differ from declaring in the build.gradle file. You could very easily, using the public API of Gradle, configure the config resolution to always force the versions that are explicitly declared in the build.gradle file. So you could do that. So thank you, guys. I'm going to have Hans now talk about Jigsaw and modularization in Gradle faster than Java 9. Thank you.